What is up, guys? This is Luke Hill for Kit Guru, and this is the ASRock X570 Phantom Gaming-ITX TB3. What a complete mouthful. Now, we know this motherboard's been on the market for a while, but we didn't look at it initially, and with Zen 2 still proving very competitive on the desktop CPU scene, and the rumours of the upcoming Zen 2 APUs, we thought it was a good time to give this small form factor gaming motherboard a spin, especially now that we've got Thunderbolt 3 testing hardware too. The main features, of course, are ITX X570 and Thunderbolt 3 via the Intel Titan Ridge controller, so about £230 in the UK. Let's take a closer look. If we start off with the motherboard itself, I'm just going to pick it up, we can see there's a primarily dark black theme. You've got kind of dark grey, silver type accents, but as this is one of ASRock's gaming type motherboards, it's still got the red touches here and there. Most notable are obviously the large VRM heatsinks, so you've got a sizable metal VRM heatsink which doubles up as the rear I/O cover, and then you've also got a tall VRM heatsink for the top section of power delivery components. You get RGB on the motherboard as is expected these days, and you actually get a row of LEDs on the rear of the PCB down the bottom which give an underlying glow, and of course software control too. The CPU socket area is interesting. Obviously you've got the conventional AM4 CPU socket, so this is obvious. But what you will note is there's no AMD brackets, and this is because ASRock chooses to use the LGA 115X, so 1155, 1151, etc. mounting hardware for CPU coolers. Now, to people who have been small form factor users for a long time, they're probably using an Intel platform from a few generations ago. So this is going to be a pretty good option for them because it's likely that their CPU cooler doesn't actually support AM4. However, for people who are buying a brand new processor and a brand new platform with this motherboard, you can't actually use the stock AMD coolers that come with many of the processors, so the Wraith coolers, which are actually pretty decent. So your preference for that feature is going to be whether you have an old cooler that doesn't have AM4 mounts, you're going to be happy. But if you're buying brand new, you'd probably just rather stick with the AM4 platform and the ecosystem for the coolers, to be fair. In terms of memory, you can mount up to 64GB of DDR4 in the 2 DIMM slots. ASRock's QVL actually highlights support for 4.2 GHz memory kits from the likes of G-Skill and Corsair, but realistically this is AM4, this is X570 with Zen 2, you probably want to use 3600 with tight timings. Also on the QVL is support for ECC memory, so if you want to give that a go, there are some kits that ASRock actually confirms as compatible with the motherboard. Overall placement for the onboard port is actually quite sensible as far as Mini-ITX goes. You've got the 8-pin CPU power connector in the top left, and this is nestled between the VRM heatsinks, so it's quite easy to hide a cable. You've got the 24-pin over on the right side of the motherboard, right on the edge, so that's good, and that's close to the internal USB 3 header, so you should be able to hide those cables quite easily. One disappointing feature for this motherboard is that there's no internal USB Type-C header, but that seems to be quite common for X570 Mini-ITX boards, unfortunately. And as far as SATA ports go, you've got 4 in total, which is quite common for Mini-ITX and probably good enough for most builders, even for this platform. These are all right-angled, which is good from a cable management perspective, but given Mini-ITX and the quirks that you have with some of the chassis, it could cause a problem. We like to usually see at least 2 outwards facing because you know you can use the outwards facing ones at all times. Fan support is pretty reasonable even for a high-end X570 motherboard. You get 3 4-pin fan headers in total. All of them are very easy to access from the CPU socket, and one of them is specifically encouraged to be used with the CPU fan header, but they all feature reasonably good control through the UEFI and through software. As far as RGB headers go, you've got 2, and one of them is the newer addressable standard. Obviously, a single PCIe Gen 4x16 slot, and this is steel plated for extra rigidity. You will note that the spacing of the slot is quite close to the bottom of these large VRM heatsinks and the chipset heatsink, so you will need to pay attention to the backplate on your graphics card. It's highly unlikely that you're going to get a graphics card backplate thick enough to cause interference issues, but if you've got some really funky things going on the back of your graphics card, like some of those cool MSI cards we saw a few generations ago, you will need to pay attention to interference. Highly unlikely to affect most people though. The M.2 connector is on the rear of the motherboard and supports drives up to 80mm in length. This is actually probably the most disappointing area of the motherboard because we only get one M.2 connector, which as far as I'm concerned is just not enough for an X570 motherboard, especially of this caliber and at this price point. You'll also note that there's no heatsink because you're very limited in terms of dimensions, but this is going to cause a problem for thermal throttling of some high-speed drives. We actually used the Gigabyte Aorus PCIe Gen 4 2TB NVMe SSD, and this thermal throttled very heavily because the heatsink was too big to be fitted in there. However, if we switch to something like a WD Black SN750, which we tried out with a relatively low profile heatsink that allows it to sit quite comfortably in the CPU cooler cutout that many chassis actually have, we saw significantly better performance by virtue of the heatsink. We wish ASRock had designed some low profile small heatsink, or just something that could have been stuck on there very easily to improve the thermal throttling situation. And like I say, just the one M.2 slot is very disappointing. Anybody who wants a secondary drive, whether that's because you're a video editor and using it as a scratch drive, just because you want more storage, or because you don't want to deal with the cable nightmares that SATA 2.5-inch SATA SSDs can cause in small form factor builds, you can't do that. You've only got the one M.2 drive, which is probably going to be housing your operating system. And that's especially disappointing when we realise just how much connectivity is spare with the X570 platform. If we jump around to the rear I/O, you'll see 4 USB Type-A ports. This is probably going to be slim for most people, but USB hubs are very cheap, so I don't see that as a major concern. You've got PS2 if that interests you at all. In terms of networking, you've got Intel Wi-Fi 6, so AX200. Gigabit Ethernet is provided by an Intel i211AT adapter. A little bit disappointed to not see 2.5 or 5 gigabit Ethernet here, but that would have added cost when a lot of people might not have used it, and you can get a USB adapter for that anyway. In terms of video outputs, you've got HDMI 2.0, so you can do 4K 60 using an APU, and then you've also got DisplayPort input. Now, why do you have a DisplayPort input? That's because you can take your video connection, you can output from the graphics card, you can input to the DisplayPort on the motherboard, and then you can use the Thunderbolt 3 connector to transmit your display connection over Thunderbolt. And in terms of Thunderbolt 3, this is using the Intel JHL7340 Titan Ridge controller, so a pretty modern controller. The Type-C connector supports 40 gigabits per second Thunderbolt protocol. It also supports 10 gigabits per second USB 3.2 Gen 2, so Type-C form of course, and then 15 watts of power delivery. Ideal use cases of something like Thunderbolt 3 are vast. You can use big external storage arrays that you just cannot fit inside a small form factor system. You can use Thunderbolt 3 docks to get plenty of additional ports, including USB ports and networking ports, or you can even use Thunderbolt 3 to drive an external graphics card, for example, or 10 gigabit Ethernet adapters. Plenty of options. I love Thunderbolt. I think it's a fantastic ecosystem, and it's really good to see Thunderbolt 3 on this motherboard. It's actually the only mini ITX X570 offering with Thunderbolt 3, so that clearly is the star of the show here. And then rounding out the rear I/O, we've got audio ports, and they're controlled by the Realtek ALC1220 audio codec, and we've got a rear-mounted clear CMOS button, which is fantastic because you don't need to open up your compact small form factor builds to mess around with any of the settings or jumpers. The VRM is a 10-stage deployment, and it's built around Intersil hardware. You've got the Intersil ISL 69147 PWM controller operating in 4+2 mode to drive the power delivery system. And because it's in 4+2 mode, you have to take those 4 control channels for the CPU VRM and use doublers. So they're ISL 6617 phase doublers, 4 of those are used. The DRMOS power stages themselves are Intersil ISL 99227 60 amp stages, and 8 of these are allocated for CPU duties, obviously with phase doubling, and then 2 of them are driven directly for the SoC VRM. The way ASRock splits the VRM is actually very smart. So you've got 6 of your CPU focused power delivery stages underneath the larger rear I/O heatsink, and then the remaining 2 CPU focused power stages underneath the small topside heatsink, as well as the 2 SoC phases. The reason this is smart is because only a quarter of the CPU power delivery stages are beneath the smaller heatsink. So the CPU stages will typically be run quite hard, they might get quite hot, so the fact that 75% of them are actually below the larger heatsink is a very smart layout move. Overall, I'd say the power delivery system on this motherboard, in terms of specifications, is fantastic. Even though you only get 4 real control phases, if you like, driving the CPU with 4 doublers, the actual hardware being used, especially those 60 amp stages, looks pretty top notch. And then in terms of heatsink designs, when focusing on the VRM, I'd give them a okay. There's no real effort to fin the blocks of metal. They are just that, blocks of metal. But given the efficiency of the power stages underneath, and realistically you can't push enough juice to stress this VRM really, really heavily when you're using a Ryzen 3000 Zen 2 chip, they should be okay. You also get the benefit of somewhat active cooling for the larger rear I/O covering VRM block, because a heat pipe connects this block of metal to the chipset heatsink, and that chipset heatsink actually houses a 40mm fan. So you get some degree of somewhat active cooling for the VRM themselves, and the chipset fan should be able to keep the chipset easily cooled, although it does angle towards a graphics card, so it will be sucking hot air off the back of a graphics card. So that's something to pay attention to. Anyway, that's enough for a closer look at this motherboard. Let's look at the test system and then get into the results. Our test system is based around the Ryzen 9 3900X. We continue to use this processor because it allows us to compare against previous X570 motherboard data, and it still pushes the motherboards very hard indeed. Memory comes in the form of a 2x8GB 3200MHz C14 G-Skill kit, which uses Samsung B-die ICs. Pixel pushing power comes from Gigabyte's beastly Aorus RTX 2080 Ti Extreme graphics card. This triple slot monster pushes the GPU performance to a level where we can identify differences between competing solutions. We use a custom fan curve to minimize thermal throttling and ensure consistency between test configurations. Power is handled by the absolutely overkill and highly efficient Seasonic Prime Titanium 1000 watt power supply. And then in terms of BIOS, we were using the latest BIOS revision with the motherboard, which is P2.00, and that's using the AGESA 1004 patch B update. If you want more details on our test procedure, the comparison hardware, and all of our settings, head on over to the KitGuru website where you'll find more details. CPU-based performance from the X570 Phantom Gaming-ITX TB3 is as good as we have seen from other X570 motherboards. Clearly, size is no problem for this contender from ASRock, and the sustained all-core frequency under loads such as Cinebench R20 and Blender was in the order of about 4.05 GHz. There were no problems with any of the memory bandwidth results using our 2x8GB 3200 CL14 DDR4 kit. Latency was also right where we expected it to be. Gaming numbers had ASRock's miniature X570 offering competing handsomely against full-sized ATX contenders. This mini ITX motherboard will be as good as ATX alternatives when it comes to gaming. Our PCIe Gen 4 SSD hit its 5GB per second levels in Crystal Disk Mark, but we had to remove the sizable heatsink to install it in the real location. This meant that even two back-to-back Crystal Disk Mark benchmark runs, or a single run with 9 read-write operations, would cause thermal throttling and a heavy drop-off in write performance. This is clearly something that is going to be a problem to users with write-heavy tasks, and that's a key audience for this motherboard. Even tasks such as copying extremely large files from a Thunderbolt 3 SSD will likely result in overheating some naked M.2 SSDs, especially if the writes are fast enough and lengthy enough. We switched to a WD Black SN750 SSD with its metal heatsink that is relatively low profile but feels extremely well built. We wanted to see how much influence the heatsink would have in being able to keep our M.2 SSD temperatures in check and therefore the speed consistent. Testing with this heatsink equipped WD Black SSD, we saw that the read-write operations were consistent and the temperatures stayed at reasonable levels too. Given the performance that we observed, we would certainly recommend investing in an SSD with a reasonably sized M.2 heatsink. The key caveat is even the WD Black's quite low profile M.2 SSD cooling mechanism is actually taller than most standoffs in a chassis, so you're going to have to hope that the M.2 SSD sits quite nicely in your CPU cooler cutout on the motherboard tray. If not, you're going to have to find an even thinner SSD with a heatsink, or just accept that you're going to get thermal throttling. Not an ideal scenario, certainly. For Thunderbolt 3 testing, we installed the Intel driver from ASRock's website and used our TechQ-based SSD enclosure with absolute ease. Thunderbolt 3 speeds were good during our testing, hitting just shy of 3 GB per second peak. This is significantly faster than 10 gigabits per second USB 3.2 Gen 2. The Realtek-based audio system is rated as very good by Rightmark Audio Analyzer, with frequency response being particularly high performance. Overclocking was very straightforward thanks to ASRock's clear UEFI. We were able to hit our usual 4.25 GHz with 1.35 volts with relative ease, and the level 1 load line calibration setting was selected thanks to ASRock's clear display in the UEFI. Voltage accuracy was good, with CPU-Z reporting a CPU core voltage of 1.344 volts. A noteworthy performance boost is obtained from the overclock to 4.25 GHz, and this helps bump ASRock's ITX board up to top spot. As the physically smaller mini ITX board is commanding more power than ATX alternatives from Gigabyte, MSI and Asus, there is clearly still room for ASRock to improve the motherboard's stock clocked voltage and power behaviour. Overclock readings with our chip manually tuned are particularly strong, as the motherboard has little else to feed compared to the larger ATX competitors. Thankfully, the power-drawn voltage data that is fed through to software such as HWM464 looks to be fairly accurate, as it corroborates reasonably with AMD Ryzen Master readings. CPU temperatures were certainly on the toasty side of things, with numbers around the high 80s and low 90s mark in our very hot ambient environment. While this is more of a reflection of our CPU cooler's performance, it does reiterate the point that there is room for ASRock to tune the stock clocked voltage levels a little further. VRM temperature readings, both via the onboard sensors and through manual readings in the relevant locations, highlight superb results. Despite this relatively small topside heatsink, ASRock's bulky cooling block that handles the majority of the VRM heat is more than adequate for even heavy overclocking. This is a testament to the efficiency of the Intersil-based VRM design. Chipset temperatures were also where we'd expect, around 70 degrees Celsius after sustained system usage. The chipset fan does, however, spin rapidly to achieve those temperatures, and we regularly saw readings of 6,000 RPM or so. This level is irritating, and we'd certainly recommend tuning a better fan curve that you are more comfortable with via the UEFI. Overall, we'd say the ASRock X570 Phantom Gaming-ITX TB3, despite its incredibly and annoyingly long naming, is a good motherboard. Realistically, if you want a X570 powerhouse with Thunderbolt 3 and all the flexibility that the Thunderbolt ecosystem brings, it's your only choice. So by that logic, a lot of people are going to be interested. The Thunderbolt ecosystem really is superb. It gives you plenty of flexibility, whether you want 10 gigabit Ethernet, external GPU enclosures, docks with plenty of connections, or really high-speed storage hanging off a single connector. It really is fantastic, and especially for a small form factor system that this motherboard will be used around. But of course, it's not just Thunderbolt that sells a motherboard, you need the performance, and ASRock delivers very well there. We were happy with the test numbers, the overclocking results were good, and the power delivery solution was actually perhaps even better than we expected, because the cooling was perfectly fine. The efficiency of the Intersil power stages underneath seems to be particularly good when we're pushing. The temperatures were completely fine, even in a particularly hot ambient, so we'd have no concerns running this really heavily for extended periods of time. The LGA115X CPU cooling mounts are going to impress some people and annoy other people. It's very good for upgraders who have an older cooler from their older small form factor system that they just want to keep and bring to this new platform. But for people who were thinking of actually using the AMD Wraith cooler, which is supplied with some of the Ryzen 3000 processors and is a pretty good cooler, you can't do it. So that's quite annoying. I would have preferred the standard AM4 mounts, to be honest, because I think these days the small form factor AM4 ecosystem for CPU coolers is good enough. The performance from the rear mounted M.2 connector was fine, provided you can cool the SSD, but this really was our biggest annoyance with this motherboard. I think including one M.2 connector on an X570 motherboard is inadequate. It's not enough these days, especially when you're going to have some cooling concerns on there. There's plenty of bandwidth on the X570 platform, even with Thunderbolt 3 siphoning off some of the PCIe lanes, so this is really quite disappointing to see only one M.2 connector on there. Even if ASRock had included a secondary M.2 connector for M.2 SATA devices only, that would have been fine in our opinion, because the ability to deal with M.2 in a small form factor ecosystem where you don't have to worry about cables, whether it's SATA data or SATA power, or just the ability to have a low profile drive in there, is very, very positive for small form factor systems. So to add to the M.2 connection, there are some other caveats. You only get one internal USB 2 header, which is annoying to people using smarter AO coolers, as well as some front panel ports, because you're basically going to have to take your pick. The lack of internal USB Type-C header is annoying, but this seems to be very common for some reason on X570 mini ITX offerings. And we would have also liked to see 2.5 or 5 gigabit Ethernet, but that's perhaps asking a little bit much, because ASRock did clearly need to hit a price target, and that would have increased the price, perhaps unjustifiably, to some users. Plus, you can also buy a USB 3.1 Gen 2 or even Gen 1 adapter if you want 2.5 or 5 gigabit Ethernet. So overall, despite those caveats, we quite like the ASRock X570 Phantom Gaming-ITX TB3. The Thunderbolt 3 performance was good. We saw that it worked pretty much flawlessly once we downloaded the driver. There really weren't any headaches with our high-speed Thunderbolt 3 SSD, so that's a real positive. And the ecosystem gives you so much flexibility compared to even USB, because Thunderbolt can do so much when it comes to displays, high-speed networking, high-speed storage, docks, etc. It really is a fantastic ecosystem. So if you want small form factor, if you want up to 16 cores from your processor, if you want plenty of RAM, if you want enough onboard storage, granted only a single M.2 storage, but then you want that Thunderbolt 3 ecosystem, ASRock's motherboard really is a fantastic choice, and quite frankly, the only choice. Thanks for watching. I've been Luke Hill for Kit Guru. Let us know what you think in the comment section down below. Would that lack of M.2 connector be a real deal breaker for you? Would you be happy with Thunderbolt 3 and all the flexibility that brings? Are you happy to compromise? Is this the perfect motherboard for you with the blend of small form factor features and that excellent Thunderbolt 3 port? Let us know in the comment section down below. If you like this video, give us a like, subscribe, do all that YouTube stuff. Make sure you head on over to the Kit Guru website to read the full written article. That really helps us out. You can also help us out through Patreon, and if you want to buy a cool t-shirt like this, head on over to our merch store. See you next time.